Hello class, these are our AP Calc AB notes for section 3.3, increasing and decreasing functions and the first derivative test. So because we did so much with first derivative charts the other day, when we did relative max, relative mins kinds of stuff, this is going to be a lot of review today. So a function is increasing if f prime of x greater than 0, which means f prime is positive. So let's think about what that means. So if we're looking at a graph of f, we know that our f prime is our derivative. It is the slope of a tangent line, so the slope at a point. So what that means is when my function is going up, so I think you'd agree that like from here to here, my function's going up, the slope of that tangent line is positive, which makes sense, right? The graph's going up, those tangent lines would have to be positive slope. A function f is decreasing if f prime of x is less than 0, which means f prime is negative. So looking at my graph again here, that would be like when my line is going down. There's something weird going on with this color. Let's see if we can just pick a different color here maybe. So that would be like this line is going down. Yep, still not working. So this would be like a line going down, right? When my tangent line has a negative slope, it's because my function is decreasing. So the function itself is going down. So we want to find, it says find the open interval. So that just means we're using interval notation. We're not using the brackets, but just the parentheses, right? We're not using a closed interval. And we want to know where our function is increasing or decreasing. So our method is going to be to find our critical numbers, make a first derivative chart, and then everywhere that our first derivative is positive, it'll be increasing. Everywhere that our first derivative is negative, it'll be decreasing. So first, we're doing all those same steps that we did for relative max, relative min. So we're going to start out by taking a derivative. Sorry about that. So let's go ahead and take our first derivative. So that means I bring the 3 in front, make it an x squared. Bring the 2 in front, 3 halves times 2 is just 3. And now we've got x to the first power. I want to find my critical number, so I would take my first derivative and make it equal to 0. I would also say where my first derivative is undefined. This one's a polynomial, so it is never undefined, not an issue here, but we do need to make it equal to 0. So let's go ahead and factor to 3x. And we get x is 0 or 1. These are my critical numbers. So just like before, I'm going to make a first derivative chart. Since it's first derivative, I'm going to label it an f prime. And we need to go ahead and plot 0 and 1. And we're looking for what's going on between them, right? Or on either side, I guess. So like somewhere between negative infinity and 0. So maybe I'd use like a negative 10 over here. In the middle, I'm going to check 1/2. And then here I'm going to check a positive 10. And we're checking it in our first derivative. And when I'm checking it, I really like this factored form that we came up with. I think that's the most useful or easiest to use. So if I'm going to plug in negative 10, I have 3 times negative 10 times negative 10 minus 1. So that's going to be a negative times a negative, which is a positive. So my first derivative is positive from negative infinity to 0. It means that my function is increasing. Then I want to check 1/2. That'll be a 3 times 1/2 times 1/2 minus 1. So positive times negative, which is negative. So my first derivative, negative, which means my function is decreasing. And then I want to check positive 10. 3 times 10 times 10 minus 1. Positive times positive is going to be positive. Okay, so now I've got to kind of wrap it all up. F is increasing. On, let's see, increasing from negative infinity to 0. And in interval notation, It's also increasing from 1 to infinity. F is decreasing in the middle there, right when my first derivative is negative. So it's decreasing on 0, 1. First derivative test, that was a relative min or a relative max. We already know this. Relative minimum at x equals c if f prime of c is, we have a minimum if first it's negative and then it's positive. It looks like a minimum, right? And then we have a relative maximum at x equals c if f prime of c is positive and then negative. And this is with c in the middle. So to the left of c it's positive, to the right of c it's negative. A function is strictly monotonic if it is only decreasing or only increasing. So perfect example of that I'm going to bring up again and again is like x cubed. Now x cubed, we know the shape of my function is kind of like this. It's increasing the entire way. It's got some kind of interesting change of shape stuff going on in the middle, but my graph is always going up. So it is only increasing. It is a monotonic function. Just kind of a vocab thing here. Okay, so our last real example we're doing is using trig, which I really like. We need more practice with trig. So same kinds of steps. Oh, this one's relative extrema. So we're looking for relative maxes, relative mins. We've got an interval again. So first step is always to take the derivative, make it equal to 0. So derivative of 1/2 x is just 1/2 minus derivative of sine is cosine. So I want to figure out when this is equal to 0 or undefined. So if I'm thinking equal to 0, I have 1/2 minus cosine x equals 0, which means 1/2 equals cosine x. So lots of different places where the cosine's 1/2. So if I'm thinking about my right triangle trig kinds of stuff, my cosine is my x over r. So I could make my x side 1, my r side 2. And then this is either root 3 or negative root 3. So I've got a couple different options here, right? The first would just be a pi over 3. The second one would be 5 pi over 3. And you might have to slow it down here to do the trig a little bit. I'm just trying to go through this. So x equals pi over 3 and 5 pi over 3. I don't have to worry about cosine being undefined. Right, cosine is x over r, and my r is just not going to be negative. It doesn't make sense. We don't have to worry about that. Once I find my critical numbers, I need to do a first derivative chart. So here's my f prime chart. Here is pi over 3. Here is 5 pi over 3. So I've got to check something less than pi over 3, something between these two, and something bigger than 5 pi over 3. And when I check, remember, we're looking at the interval from 0 to 2 pi. So it needs to be like between 0 and pi over 3. So I'm going to check x equals pi over 4. Between the two, I feel like pi would be a real easy thing to check. And then greater than 5 pi over 3. But again, not as big as 2 pi. I'm going to use 7 pi over 4. Because as long as I've got a multiple of pi over 4 here, I should choose one here as well. I could also use like a pi over 6 and something pi over 6 over here, right? We could do the same thing. Like 11 pi over 6. All right, so I've got to check some different values, and we're checking them in our first derivative. So when I'm checking pi over 4, that's going to be 1/2 minus cosine pi over 4. So let's go ahead and figure that out. Let's go ahead and draw out cosine. Pi over 4 is right here. That's going to be 1 root 2. So my cosine would be 1 over the square root of 2, which is root 2 over 2. So if I think about same denominator, subtract the numerators, 1 minus root 2 would be like a 1 minus 1.4. So it's going to be negative. So let's go ahead and draw on our first slope. Then I want to try pi. Pi is going to be pretty easy. So 1/2 minus cosine of pi. Well, cosine of pi is a -1. So 1/2 minus -1. Minus a negative is going to be plus. That one's going to be a positive. So I'm going to draw my line going up to show positive. And then I'm going to go back and do pi 7 pi over 4. So 1/2 minus cosine 7 pi over 4. Oh, 4, not pi. So let's go ahead and do the last one. one root 2, and this is going to be a negative. My cosine's still positive, though. It's going to end up being the same as the first one. 1/2 minus root 2 over 2. So this is going to be a negative again. So let's see, what do we got? We've got a relative minimum. Of something at x equals pi over 3. That's going to be my relative minimum. I don't actually know what the minimum is yet. I have a relative max of something at x equals 5 pi over 3. So I'm still going to have to do a little bit of work here. So let's go ahead and figure out my relative minimum. We got to go back to our function. I don't even know where to put this. We'll put this over here. So at x equals pi over 3, we would have 1/2 x minus sine x. And if we go back to where we have a pi over 3 drawn, sine of pi over 3, here's my pi over 3 picture up here. And sine is my y over r, so it's root 3 over 2. So this is going to be pi over 6 minus root 3 over 2. Multiply by 3 on the top and bottom. And I would have pi minus 3 root 3 over 6. Okay, and then for my relative maximum, so let's see, we've got x equals 5 pi over 3. Back to my original function. My original function, remember, is f of x equals 1/2 x minus sine x. That's what I'm using. So this is going to be 1/2 times 5 pi over 3 minus sine 5 pi over 3. Well, that's going to be this triangle right here. This is the 5 pi over 3. So it's going to be negative root 3 over 2. Negative minus a negative is going to be plus. Multiply this one by 3 over 3 as well. And we would have, let's see, 5 pi plus 3 root 3 all over 6. All right, a little bit of trig here. I think it's good for us to see. It really is. The trig is not going away. It may take a little while to slog through it, work all of these out. Might have been faster to use decimals, but you know me, I never have that calculator ready, and I really think we need to practice this anyway. I think coming up with the decimal answers is not really what we need to be practicing at this point. So big ideas today are just that we can figure out where a function is increasing or decreasing based on whether our derivative is positive or negative. And then kind of a review of relative max and relative min. So as always, class, if you need help, please make sure you ask.